We're at video CA number 10. If you're following along in the series, this is from chapter 1.6. I'm going to break this chapter into 3 parts because it's pretty intense. This first part is on rational expressions. We're going to look at how to simplify, multiply, and divide rational expressions. In the description, there's going to be links to the textbook that I'm referencing, to my lecture notes, and also some review videos on factoring, because this section relies very heavily on the skills that we learned in the last section. So if you're a little bit wobbly on those, check out some of these videos. Okay, let's get into the book and get started. So what do we mean by rational expressions? What we mean is a fraction that has polynomials, and we want to reduce it down. And we're going to use the same techniques that we've always used with regular numerical fractions. So for just a second, let's go back and think about what we used to do. Because a lot of times at this point, you've been using a calculator so much, you've gotten a little rusty on the actual process. But you can't use the calculator, not your calculator, on this. So we need to figure out, how did we actually used to do this back in the day? If you had a fraction that you needed to simplify or reduce, well, you looked for a number that would go into the numerator and the denominator. Now, like this example, 2 goes into both of them. So what we did is we divided the top by 2 and we divided the bottom by 2. As long as you did the same thing to the numerator and the denominator, you were okay. So 6 divided by 2 was 3, and 10 divided by 2 was 5. But I want you to look at this another way. What you actually did is you factored the numerator and the denominator into a set of factors that had a common number. So for example, 2 went into both of these. What you actually did is you said, okay, 6 is equal to 2 times 3. And you said 10 is equal to 2 times 5. Now, what is any number over itself? It's 1. So we said, okay, this makes 1, and 1 times everything is that number. So that's how technically you came up with the reduction of 3/5. We're going to use something along the line of this, because you can't just look at a polynomial and tell what number or what binomial goes into it. So this is actually what we're going to be doing with our polynomials. Let's grab one and look at it. Now, before I show you what you can do, let me take a minute and show you what you cannot do. The only thing that can be reduced in a fraction or rational expression is a factor. Factors are multiplied times each other. So what you have up here is 2 terms. What you cannot do for this expression, you cannot cancel these 2. Because what you actually have here, let me write that down, is x over 2 plus 2 over 2. So you could rewrite that as x over 2 plus 1, but that's not really any more simplified than this. Okay, let me show you one more thing that you cannot do. In this example right here, 4 plus x over 2 plus x. You cannot reduce the 4 and the 2. You cannot reduce the x over x, because those are not factors, they're terms. In expanded form, what you have here is 4 over 2 plus x over 2 plus x. Okay? So none of this can be reduced. If you had a problem like this, now what's the difference here? These are added, these are multiplied. If you had this, then you could reduce. The 4 and the 2 would reduce down to 2. The x and the x would reduce to 1. 2 times 1 is 2. So multiplied, you can reduce. Added, which makes them terms instead of factors, you cannot reduce that. This is more along the lines of what we're going to be looking at in the section. So I have x squared minus 9 on the top, and I have x squared plus 4x plus 3 on the bottom. I know that the only thing I can do to simplify is reduce by factors. So the first thing I'm going to do is change this into factors. How do you change something into factors? Well, you factor it. How do you do that? Using those techniques that we learned in lesson 9, the last video. So like I said at the beginning, if you're a little bit foggy on those, you need to visit some of those links that I have in the description and refresh your memory. X squared plus minus 9. See, now I have two mini problems. I've got to factor the numerator and the denominator first. So, let me take x squared minus 9. It is a binomial. How do you factor two terms? You look for a greatest common factor. There's not one. This is a difference of two squares. So it factors into x plus 3, x minus 3. So my new numerator is going to be x plus 3, x minus 3. Now I've got two factors. Alright, now let's look at the denominator. This is a trinomial. So I'm going through my steps. I have no greatest common factor. I also have no coefficient in front of the first term. So to factor it, what I'd want to do is make a chart under 1 and 3. I'm looking for the pair that adds up to give me the middle term. And that's the only factor there is. So this factors into, if it's a plus sign, your signs are going to be the same and they're going to be whatever this is. So I've got x plus 1, x plus 3. Okay? Now, fully factored, so I can cancel any terms that match. And they don't have to be right on top of each other because of the commutative property of multiplication. I could switch the order of these and it's still the same. So what matches? X plus 3 matches this one. Now did I just cancel them out? No. They divided out to 1. And what happens when you multiply by 1? Nothing changes. So what do I have left over? I have x minus 3 on the top and x plus 1 on the bottom. This is the simplified version of my original problem, and this is the correct answer. Moving into multiplication, this is example 2 on page 85 in the textbook link below. I have x squared plus 4x minus 5 over 3x plus 18 times 2x minus 1 over x plus 5. Now if you remember from your regular fraction techniques, how do you multiply fractions? You just multiply the numerators together and the denominators together. So what I actually have is this. I have a pen that doesn't write anymore. I have this multiplied times this. So of these four factors, what I need to do now is factor each factor. Alright, let's look at this trinomial. Going through that list, is there a greatest common factor? No, there's not. So if I take x squared plus 4x minus 5 and I get ready to factor it, well, it's going to factor into two binomials. What signs am I going to have? Since this is a minus, I'm going to have one of each, a plus and a minus. This does not have a coefficient in front of it, so this is the easy one. I just have an x and an x in my first term. The only challenge here is to find the numbers that go in these second positions. Alright, these two numbers have to multiply to give me negative 5 and add up to give me positive 4. Well, what about positive 5 times negative 1? Isn't that negative 5? Yes. Isn't positive 5 plus negative 1 equal to positive 4? Yes. So that's going to be there. This is going to become my new numerator. I'll rephrase it as x plus 5 times x minus 1. Alright? 2x minus 1. It's a binomial. Is there a greatest common factor? No, there is not. Is it a difference of two squares? No, it isn't. So this can't be factored anymore. It's going to stay like it is. Alright, let's come down here. I have a binomial. Do I have a greatest common factor? Ah, yes. What will go into 3x and 18? 3 will. So when I factor that out, I have x plus 6 left. Okay. Now look down here. I have x plus 5. Everything is fully factored, so all I need to do now is cancel out the things that match. Well, this x plus 5 matches this one. They divide out to be 1, which I don't have to consider anymore. Nothing else matches. So your simplified version of this is going to be x minus 1 times 2x minus 1 numerator and 3 times x plus 6 on your denominator. All we managed to do was cancel out these two factors, but if you hadn't factored your original expressions, you wouldn't have been able to cancel those out. Let's look at one more example. 3, page 86. This is a division problem. I've got 2x squared plus x minus 6 over x squared minus 1 divided by x squared minus 4 over x squared plus 2x plus 1. How do you divide fractions? Remember that phrase, keep, change, flip? That's what you're going to do. When you divide fractions, you multiply by the reciprocal. So the first part is not going to change. I'm going to change the division sign to multiplication, and then I'm going to flip the second fraction so that now my denominator is on top and my numerator is on the bottom. Now, I have 4 polynomials here that are multiplied together, and they must all be factored. So you're going to have to factor 4 problems before you can work this problem. So let's get started. When I take this first trinomial, 2x squared plus x minus 6, and this will be a good review in factoring. I look at it, there is no greatest common factor. I count my terms, there's 3. So I know I either use, if I have a coefficient in front of that first term, what method do I have to use? AC method. So I'm going to multiply 2 times negative 6 and get negative 12. And when I factor that down, I'm going to have negative 1, 12, 1, negative 12. I'm looking for the pair that adds up to give me a 1. So negative 2, positive 6, positive 2, negative 6, negative 3, 4, 3, negative 4. The coefficient of this is 1, positive 1, so I'm going to pick this pair. So I'm going to come over here and I'm going to rewrite this trinomial as 2x squared minus 3x plus 4x minus 6. Remember, your AC method, you are converting this to a 4-term polynomial so that then you can factor by grouping. All right, what do I get when I factor out the greatest common factor from this? I get x times 2x minus 3. And over here, the greatest common factor is 2. So I have 2x minus 3. Here's your matching parentheses. So that becomes your first factor. And then you have x plus 2 for the second one. So this first trinomial factors into 2x plus 3 times x plus 2. Okay, and that was the hardest one, so calm down. Alright, now let's look for this trinomial over here. Let's factor it. I'm going to take x squared plus 2x plus 1, and I'm going to factor it. Now this is not an AC method. How do I know that? Because there's no coefficient in front of this, so it's going to be easy. Since this is a plus sign, my signs are going to be the same, and they're going to be whatever this is. So it's plus and plus. All right, unfoiling tells me what would I multiply here and here to get x squared? X and x. My second two numbers need to multiply to give me 1 and add up to give me 2. So that's 1 and 1. So now, for the rest of my numerator, I have x plus 1 times x plus 1. Now, could I write that as x plus 1 squared? Yes, you could, but we're still not through. We're not through factoring down yet, so let's don't undo what we just did. I string everything out. Okay. The next thing I need to factor is x squared minus 1. Obviously, it has no greatest common factor, and it is a difference of 2 squares, so that easily converts to x plus 1, x minus 1. Difference of two squares formula. Same thing over here. I have no greatest common factor. I have two terms. They are perfect squares and they have a minus sign. So they're going to factor into x plus 2, x minus 2. Everything is fully factored. You can check them again to be sure, but they're fully factored. No greatest common factors or anything like that. Now, whatever matches up and down can cancel. So I can cancel this x plus 2 with this one. I can cancel this x plus 1 with this one. And what do you have left over? Well, you have 2x plus 3 on the top and x plus 1. On the bottom, we have x minus 1 and x minus 2. Now, do you need to go back and multiply those together? Not usually. You know, check your directions because that's what's going to tell you. Usually you want to leave these in factored form because you went to a lot of trouble to get it there. Okay, like I said, this is the first of 3 videos for section 1.6, but you are ready at this point to work problems 1 through 32 on page 89. I would at least work all the odd ones and check your answer in the back of the book. If you're flying right along, then you're going to be in great shape because our next section is going to be addition and subtraction of fractions. So that's going to have an added layer. Okay, I'll see you back here in video number 11. Bye.